Testing, testing, testing.
So let's get some feedback.
Casey. Yep. Go ahead and unmute yourself.
I should be unmuted.
So, Casey, can you hear? Are you on? I think you're the only one I see on.
See chat. Please let me know.
Yeah, that's what I said. I always want to make sure this thing. Okay, so she can hear.
Okay.
All right. All right. So let's see here. So basically, what we're going to do today is we're going to go through from soup to nuts how to extract the data for the project. So give it a whirl. When's the deadline? Monday? Okay. So if you get hung up on that, send me an email. We can always back the deadline up. I don't want you like spinning off into the ground in a stress pool. Okay. So we'll do this today. Give it a good faith effort over the weekend so you can get it done. And then if you're having trouble, if you're stuck on something and you need an extra day, that's fine. Okay. Just drop me an email or let me know. I'm going to have Kyle take it away from here. So go ahead,
Okay.
Kyle.
So I have it's lecture 4 up on the side. I have the mini projects. So we might pull those in and please.
You're not sharing it.
I'm not sharing it. I'm just saying it's on the side, so I might bring it in.
Okay.
When we go to measure the stable river meanders and whatnot. And please, I'll just show the tool. So if you want to get into the best practices on how to measure that, feel free to chime in.
I've got to get to the library and get that hay and thorn paper. Because one of the things that occurred to me is that the arc length is not really specified in HEC 20. So that's the notes in there. And I thought, well, we need to figure out what the arc length is going to be. So maybe Kyle, you can cook something up on the fly here, and we can revise that. It's only one small part of the whole thing, but it does play a role. So go ahead.
Okay, so first we're going to go to the MSDIS site. So we'll Google search MSDIS LiDAR, and we should have here in the if we go to the second link where it's digital elevation model data, we'll click on that. And we can scroll down and get if we click on the 10-meter DEM data, it should pull up the Missouri map. So again, second link, come down to 10-meter DEM tiles and click down to download 10-meter DEM data. So welcome to the Missouri map. We're going to turn on the Missouri LiDAR DEM index. And initially we'll see some green, but all the LiDAR scans might not be visible from this perspective. So we'll zoom in, and we're actually going to do this on the little piney where Beaver Creek comes in. Dr. Holmes and I got together last night and looked at it. So here's Newburgh, and we're going to be getting these 6 tiles here in this array. So if you want to download any of the data, you can just click on the tiles. All right, and we can download this. I'm going to browse. I'm going to save it. Okay, and it's going to save to my download. So I'm going to go ahead and download the rest of these, and then I'll go move those files to where I can use them in QGIS. So if yours is running a little bit quicker than mine, go ahead and open a new QGIS project on the side, and I'll finish downloading these. And
Hey, Kyle, what's the name of this site?
this is msdis.missouri.edu. But if you Google search MSDIS LiDAR, it should be the second link that says digital elevation model data.
Okay, thank you.
Yep. So now let's see here if I got all of these. Okay. Some stuff on the other side here, and I'm going to go to my files. So I should have 6 files here. 2, 3, 4, 5, 6. Okay, on my desktop, I'm going to create a new folder for this tutorial. So let's just new folder. This will be QGIS tutorial. And I'm going to move these in here. So this is just file management. You could put them wherever you need them. Move them to the desktop first. And then we'll go into the QGIS tutorial. Okay. So we want to know where these are at so we can access them with QGIS. So that's how you download the data that Dr. Holmes is going to want you to use, which is the state LiDAR. I showed another method last time, but I think this is the preferred method for the mini project, correct?
Yeah, well, I was unclear on where you got that last time.
So last time I went to the national map.
Oh, yeah. So the national map is fine. I think this is better data. Is that right?
I don't know.
This
It depends
is
on
10-meter DEM post spacing. So what's the?
So the national map can have, depending, 1 meter DEM, which is dependent on. So if we do the 1 meter and we click show, so this is where they have 1 meter resolution.
So
That's typically LiDAR derived.
Yeah, that might actually be better data.
So if you have coverage for 1 meter, you can use 1 meter. I showed how to get this by dropping a point or whatnot. You know, if you're doing this creek here near Mountain Grove, you might be out of luck because there's no coverage there. So
what's inside the data that you downloaded exactly?
So those are rasters, and each pixel has an elevation value. So the resolution determines generally what area on the ground is represented by 1 pixel. So this would be each pixel represents 1 meter by 1 meter. All right, so that's actually really tight. That's a really good resolution. The 1/3 arc second is the topo that you get on the National Map Viewer. And so it's 1/3 arc second resolution. I don't know what that translates to on like units on the ground for meters, but it's not as fine a resolution as 1 meter.
So let me make sure we understand your question. Are you understanding Kyle's explanation?
Kind of. I mean, I can see he's downloading the squares, but I'm just asking him like, okay, like what's actually the data that he's downloading?
Well, it's basically a point cloud of data. Okay, so each pixel has an X, Y, and a Z in essence. And so it's got a XY, which is its location on the earth, and then a Z, which is the elevation of that pixel, that 1 meter by 1 meter pixel. Does that make sense?
Yeah, thank you.
So, and we can look through this. Yeah, question. From the Missouri site? I don't know. What site are you, or where you at?
Let me look at where you're at.
So, while we're getting this question answered, I'll just show you how to find these, and then we'll pull them in and we can actually visualize them. So you'll have to look in the browser here. If you're on a school computer, which I actually don't see anybody here on a school computer, which means everybody's on their personal computer. Under home, you should be able to find your desktop or wherever you saved it and go to it. Mine's in the S drive, so I go to desktop. I go to my tutorial file, and then I can just highlight these. So I click the first one, clicking shift, and then I'm going to drag them down into the layers. Okay, so when I do that, let's close these up. It's going to represent the raster images that we downloaded.
All right, we may have to download your image.
So the higher elevations represented by lighter color here, and then darker is obviously our valley section. So is everybody comfortable downloading data right now?
Well, we've got, so you may end up getting a signal on the bottom of when you're downloading it, because I'm getting it says this type of file can harm your computer. Do you want to keep it anyway? I'm saying keep, and then it's just going ahead and downloading it. But some of you are getting a thing that says it's corrupted, and I'm not sure what to do about that.
So the reason why that is, my understanding, this is a disk image file. So you could, like, let's say you have a CD-ROM of a program and you want to share it without actually plugging in a CD. This would be the file format. I don't know why Missouri is sharing their data like that. But QGIS is just reading it as just like an image. If you download from the National Map Viewer, let me drop a point here. Let's see, where's Newburgh at? It's over here. So this is about where we're at. If I drop a point and I search products, if you see the format, it's GeoTIFF, which is just another type of image file. And so you can download it as a GeoTIFF and pull it right in.
So the moral of the story is I'm not requiring you to use the MSDS site. It's just a site that most people in the state of Missouri use. When I've gone to meetings and talked about this thing, people use it, consultants use it. You use the National Map Viewer, that's fine as well. In fact, it may be better data. And so whatever you get, just use that, okay? And if you're still having trouble, then we can help work with you.
So just to give you an idea of how much larger this file is, it's still downloading here in the bottom. It's covering a larger area, but it is much bigger because we have a higher resolution. So there's more data included in that file. Are there any questions on data downloading?
So can you do this off of a school computer?
Should be able to.
Yeah, I mean, I just downloaded it. I'm on my school account. There were no issues with it.
Okay.
Yes. So, just basically bring a USB stick and do it on down the lab or something, maybe fast, and then take it home.
All right, so one of the things we talked about last time was how to add different XYZ tiles so you can get the background layer. So let's see if this is going to have what we need. We should have a short list for the Google tiles in one of these here. Let me add. Google satellite. Here we go. This has the links in it. So we'll scroll down. Here are the links that we'll put in for our connections. So let me go ahead and split my screen again.
So you just got one tile in there right now, right?
Yeah, I just have the data that we downloaded, but it's really hard to tell where we're at, right? It's really hard to contextualize.
So let's go back. How did you get the data back in there? Because I think people were kind of fooling around with other things. So how did you get the data?
I went to the browser, I found where I put my data, and then I just selected all of them, clicked and dragged them in.
Into the project.
Just into the layers area down here. So another thing you can do is you can add a group. So we'll add a group and I can just say raw DEM. And then I can move all these into this group. This is just organizational stuff that will help you. So if I don't want to see them, I can just one click, turn them off, okay? So I want to know where we're at in the world. So I'll scroll down to XYZ tiles, and by default, OpenStreetMap is available. But I'm going to create a new connection, and I'm going to title this Google Satellite Hybrid. And I'm going to copy this link address here. I'm going to put it in the URL and hit OK. So now we should have Google Satellite Hybrid. I'm going to try and drag this in and see if it worked. And it did. So I'm going to pull this all the way down to the bottom. So that's my underlying layer. So this is going to show me, roads as well as the underlying imagery. There's a lot of different sources. I'm trying to think of the name of it. There's some unique ones out there, and all you have to do is like create an account, but it's all free. So some of these will require authorization tokens and things like that. But if you're getting into that, you'll be able to figure that out. So we're just going to rock and roll with the Google Satellite Hybrid here first. So if we can look through this, which we'll change the transparency, we'll have an area of interest. But what I want to do first is I want to stitch all 6 of these rasters into a single raster, because my interest area is here in the valley, and that's represented a little bit by this one, a little bit by this one, and by these others. So I'm going to merge all these rasters.
Kyle, like a quick question. Are you going to actually show them how to clip too, in case they need
Yep.
to clip?
Yep, I'm going to show that. So we'll primarily be working in QGIS from here. So I can come up here to raster, and I have a bunch of different options. There's analysis, projections. This is how we would reproject. And then I can merge and do other things here. This is the clipping tools. Most of your raster tools are here. If we want to look at our other tools, we can go to processing and then click the toolbox, and then we can search the toolbox. So we can search raster, and then we have a bunch of raster tools available to us, okay? But I'm going to do merge. So I'll just search merge and look where we're at. GDAL raster miscellaneous. This is our merge. So we'll double click this.
And that's also up underneath the raster.
Under the raster drop down. Yep. So this is our dialog box. I will select the layers I want to merge together. These are going to be all of our digital elevation layers. Hit OK. And then we have options to place input files into separate bands. So you could consolidate a bunch of data. Let's say you have like a raster and a bunch of historical rasters. You could just say, this is my area, and each band would be like a different year. So you can do things like that. We're going to make this just a single raster as is, and we'll click run. And it's going to process all this stuff. And we should now have a single merged raster. So I'm going to pull this outside of
Let me stop you.
our raw DEM. Yeah,
We talked about a world file or a projection file.
I'm about to go through that now.
It was downloaded as part of when we got the projection, or when we got this LiDAR data, or we're going to have to actually download a projection file.
So here we can actually select projections within QGIS. In RAS, we'll need a projection file. So I right clicked on one of the raw data files, and if I go to information, it has an unknown coordinate reference system. So it's unnamed, NAT 83. Our parameters, let's see what our units are in. Our units are in meters. This looks like it's state plane, but we can double check. So if we come over here and go back to the Missouri map, and then let's go back to the LiDAR, we should be able to get some metadata about this. Citation, description. This might be something we'd have to dig for. So QGIS will use what's called ballpark transforms. So here it'll say use ballpark transform from our project coordinate to the unknown coordinate reference system. So we can click details on that. And it says between our UTM zone 15 north and our unknown, possibly incorrect choice. So we would want to confirm this. It looks like it's still on.
Pretty good.
So I'll double check my properties for my merged. Again, it's selecting our transformation. I'm typically just going to hit OK to see what coordinate reference system we're in. And so for our merged, it is in zone 15, so UTM, and we should have meters as our unit here. So our width is 4,500 and our height is 3,000, which makes sense because I don't know if anybody noticed, but in the raw DEM, they're 1,500 by 1,500. So we've got 3 in the width and 2 in the height. So that all looks good. We're in the right CRS for our work, so we'll hit OK. So now we have a merged file. We want to save this, so we'll go down. I'm right clicking on this. We'll save as, and then we'll select our location. I'm going to go back to my QGIS tutorial, and I'm just going to say Mo 10 meter DEM, and then merged. And I'm going to save it as a GeoTIFF. Okay, have the right CRS. We have the right resolution. Okay.
And the GeoTIFF, saving that as GeoTIFF makes it easier to get it in HECRAS.
Yes. Yep. So
They're aware of that.
yeah, I don't know why these are disk image files. See if this one wants to pop up. But using GeoTIFF is going to be better for what we're doing. So now we can go in and we can make this transparent. So let's go properties, transparency. We'll bump it down to like 60%. And then we can kind of see the underlying areas that we're representing. So any questions so far? Has everybody been able to follow along? Hopefully this is like the second or third time you're seeing this because the tutorial's up and we went through this a little bit on Wednesday.
Makes sense so far?
Okay, so this would be, if we were okay with this and we wanted to pull this into RAS, we could pull it in as we want it. But if we're only looking at a certain reach, we can actually clip this raster. And in order to do that, we need to create a polygon vector file. So I'll come up here, I can do layer and then create a layer, go through that direction, or I can click this button, which is new shapefile. So I'm going to click the new shapefile. I'm going to choose where to save it. So I'll go down here to QGIS tutorial, and this will be raster clip. Or I could say area of interest polygon. We'll do that one a little bit better.
That'd be a little more straightforward.
So area of interest polygon. My geometry type, I want this to be polygon. My coordinate reference system, I'll look up UTM 15 wait. UTM 15,
North.
and I want the 15 north. I want it NAD 83.
So, okay, so I want to stop you there. That's an important thing there. So you can get UTM on all the different horizontal datums. Make sure you're in 83, NAD 83 for the horizontal. And does it also, I don't think it does anything about the vertical. So it's all an XY kind of projection.
The ellipsoid is GRS 1980.
Yeah.
So hit OK. And then we're not going to create any new fields. If we knew we were going to do some other analysis with this, we might add the fields here, but we're not going to. We'll hit OK. So let's just double check that I selected the right coordinate reference system. So NAD 83, UTM zone 15 north projected. OK. I'm going to look at this, properties, bring this over here. And we have the same coordinate reference system. Okay, so we're consistent through that. We'll hit OK. So now I'm going to create my area of interest. So I have this nice little pencil up here that will toggle editing. I click that. Now I have different tools available. So I can just click this button to add the polygon. If I want to adjust things, I have my vertex editor. So I'm going to add the polygon. And do you want to just split it from here, kind of capture this area?
Yeah, just get rid of the upper, like the Beaver Creek stuff. Just go from down the confluence over.
Okay, so I'm going to cut it. We'll go about here. And I'm generally going to make this rectangular. You could click along here and only capture the channel bed if you're interested in that. So once I have this, I can right click and it will be done. I'll just give it ID 1 and hit OK. So now we have our coverage. I'm going to toggle editing and click save. I want to just confirm that this is where I want it. So I'll go to properties. I'll go to symbology and I'll make the opacity lower so I can see through it. Are we good with that? Do we want to capture any more area?
Good.
Okay, so that looks good.
Well, wait a minute, time out. Just in case they need to edit. So can you go up to the vertex editor?
Yeah, so whenever you turn the toggle editing on, make sure you have the layer you want to edit selected. So I'm going to toggle editing. I'll go to my vertex editor. I'll do my vertex tool, and I can click on these and drag them around and kind of change things. I can add a vertex if I want. I could click.
Go ahead and add one just for grins.
I can click here and trim it up a little bit. It will click here. Now we can trim it into what we're actually interested in. And we'll leave that as, we can leave that as is.
Okay, so slow down this part here. So show them how to save it and then get out of the editor.
So I can just turn off the editor and it will ask if I want to save changes. So I can click save. We'll go ahead and do that. And so now I have this polygon and it's saved. So now we're ready to clip this raster and just take the data underneath. So if I go to raster and I go to extraction, I can clip by a mask layer. I could also clip by an extent. So if I was like, if I was zoomed in right where I wanted to get the data, I could just clip it by the extent of my window. But we're going to, let me zoom back out here. We're going to clip by mask layer. So our input layer is going to be the raster that we want to clip. So we're going to select our saved one. Our mask layer is the polygon we just created. We can make these, we can input these coordinate reference systems. I know the source is this. I want my target to be in the same. So I can add those or I can leave it and it's just going to take those values. I want to keep the resolution of the input raster, or I could set the output file resolution. So maybe I don't need to be as coarse. Let's say we have a bunch of LiDAR data. I can save some time and some space on my file by doing that. those are the resolution parameters. We'll save it to a temporary file. We can save it to a permanent file. Typically run a temporary file, check it, and then save it. So I'll hit run. It's going to go through there. It says, let's see, go to the log in the main.
Didn't like something.
Okay. Local data processing temporary. You can check the log messages panel. So let's leave this up here. Let's go to view. We should be able to panels, log messages. No such file or directory. Interesting. Okay.
Well, in the interest of time, so that's how you would clip it. I think what's got it is because we're on the university system, there's probably some sharing issues here. You know how to do it, right? And you don't have to clip it either. You don't have to, you can build the tile and just use everything, just uses more memory space, right? So just go ahead now, let's head on to pull this into HECRAS and stuff. I'm afraid
Yeah,
we're gonna run out of
interesting.
time.
Okay, well, we do have our merged DEM, so that's good and well. So let me open up RAS over here in my apps anywhere, and then I'll bring it over. Do you have any questions about QGIS while I wait for RAS to load up?
So just to be clear on what we're doing here, when we were working on Wednesday, the idea was we're going to use QGIS for everything. So there was so much confused looks. I said, let's bag that. And if you know how to do that, proceed. But if you don't, and you got confused with all these different things that Kyle was showing you, HECRAS is a little coarser. It's not as pretty when you get it out done, but it's probably going to be something more useful to you because we're going to use HECRAS later. So now we're going to basically pull this into RAS, and then you're going to extract things like channel width, cross-section properties, slopes, all. We're going to get that directly out of RAS instead of using QGIS. So Wednesday was just using all QGIS. All right. Now what we're doing is, okay, well, we've got that, but if you're confused, you can use this method, which is going to be, we have to use QGIS to clean it up, to massage the data, to pull it into RAS. But now we're going to pull, now that he's done that, now we're pulling into RAS. He's going to start doing the manipulations to get the data you need to do the project.
That's a good point. So let's open RAS. We have to create a new project. So I will go through and I'll save it to my QGIS tutorial file. And I'm just gonna.
Okay, we're not seeing that.
I know. I just got it on the side. I'm labeling it tutorial. Everyone in here should be through water resources, so you should know the ins and outs of creating a recipe.
I'm not. I'm still
Okay.
in water resources.
Okay, so
we have a few.
You will learn. Okay, so let's hit cancel really quick. So let me pull this over. I clicked file, and then create new project, and then I navigated to where I wanted to save it, and I'm going to give it the title of tutorial. You can change the file name because whatever file name you give, everything's going to have that name and then a different like ending here where we have like PRJ. So I'm going to label it tutorial, and then title, I'll just make it tutorial as well. And I'll hit OK. And it says, do you want to start a new project with this? Unit system will be US customary, but can be changed. I'll hit OK. So now I have my project file. Now I know we're working in meters here because of our projection. So I'm going to go and I'm going to select the unit system under options. Everything's going to pop up on the other window. And I'm going to select the metric system and hit OK. And it will tell me it's not going to convert values. So let's say you put all your units in, like we left it in as US customer, you put all your units in, you realize, oh my gosh, I've measured everything in meters, but I want my output to be in US customer. You can convert all of those to feet through some of these tools. So this is just saying, hey, you're not converting your project units. You're just saying these are actually meters, not feet, which is what we're doing. So we hit yes. Now, in order to use the RAS mapper tool set that we're going to be doing all of our analysis with, we need to get a projection file. So before we even get to the RAS mapper, I want to show you how to find the projection file. We've talked about the projection we're using in this being NAD 83 UTM zone 15 in or 15 north. So if you search spatial reference UTM 15 north, here you have a bunch of different options, right? NAD 83 just so happens to be the first one. You click on that. Here are a bunch of different formats to download that projection file. And the way RAS sets its projection, it needs a .prj, which is not the project file, but the projection. So we can.
All right, so real quick,
Go
I
ahead.
hate to interrupt you, but I see points where they're going to get screwed, wrapped around the axles. HECRAS has a naming convention. The overall project is named .prj. That is not a projection file. It just so happens that projection files are also a .prj. So make sure you keep that straight because it can get confusing. So there's a whatever, Kyle named the project QGIS tutorial or something tutorial. So it'll give that overall project tutorial.prj. He's getting ready to download a projection file. He's going to give it some other name. That way he keeps it straight, but don't get those confused. I can see where that would hang people up.
So typically the naming for your projection is going to be the EPSG number. So this is going to be 26915.prj. So I'm going to save this file and then I got to go move it over to my project folder because HECRAS is going to look for it there. So let's open a new window, go to downloads. Here it is. I'll just drag this right over. And so you can see they're both .prjs, and that could get confusing. Let's move that in one here. So we'll minimize both those things. So now we just have RAS to play with. So we click on the RAS mapper, which is this little map icon, and it should bring up this window. Get organized here for a second. We click on tools, we want to set the projection for the project. So we'll click on that. And then it's going to ask for the Esri projection file. So if I open this up, I'm by default looking in my QGIS tutorial. You can see we also have our shapefile projection. So I think we could use that because that's just representing the same projection. But since we downloaded it from spatial reference, and just to be consistent, we'll use this. That way in our metadata, it's not saying some shapefile name projection, right? So we know. So we'll open that and it'll load in. We can see the projections, North American datum, 1983, UTM zone 15 north. All right, so that all looks good. We're gonna change this to meters. That way, so what this is asking for the cross-section river stations, when we draw our line in, it will automatically number our cross-sections with a river station. Typically that's feet upstream, right? Or it could be miles upstream. So you have options here. So you could say or kilometers, miles, feet. We're just gonna say meters because we're working at a small area of interest. We'll hit okay. Now we can add our terrains. So here we have geometries, results, map layers, and terrains. If I right click on terrain, create new RAS terrain, this dialog box comes up and I can input the terrain files. So I can hit plus. Now I could, if I had those files we downloaded from MSDIS as geotiffs, I could just click all 6 of them if I didn't want to click any of them and pull them in like this. It will stitch all of them together and do all that. But we've already done that and we've saved it as a geotiff. So we'll click our merged file. We could also pull in just the raw 1 meter data. And maybe I'll do that here in a second to show the resolution difference.
Just to clarify too, just to emphasize, what he downloaded off of the MISTIS site was not a geotiff.
Correct.
So you cannot pull those directly in. That's why we have to go through QGIS to do this. We have to create them as geotiffs. And that's what he's done by merging them, putting them out as a geotiff. HECRAS will not accept the format that state of Missouri puts their stuff out in. Now the USGS site, those come out as geotiffs, but they're much larger. So you could have ostensibly pulled the USGS stuff in. Now it might be a huge site and it might be, the more data you get in there, it bogs down the application. So you want to clip that stuff. So anyway, go ahead.
Yeah, so let's just look really quick. So this is our 10-meter DEM merged. Our size is like 52 megabytes. And then the 1 meter, which is it's covering a larger area, but it's 471 megabytes. So I'll pull both in and we can look at them shortly. So we have our merged GeoTIFF, our file name. If we open the file, we're going to save this as a terrain. So I'm going to label this 10 meter, or let me be consistent with what I've got here. Let me hit close here. Mo 10 meter DEM merged. So we'll just name it the same, or I think it's 10 meter DEM. So that's going to be the terrain file. I'll hit save, and then I will click create. And this dialog box is going to run. Typically it goes pretty quick. This is actually the longest I've seen it take, but maybe it's the school computer here.
So while we're waiting for that, I think if we have enough time, we can go back to the USGS one, but
Sure.
we'll see through the HECRAS stuff. At least get it before students have to leave.
Yeah, because we got what, 10 minutes left, something like that.
Well, we'll keep going. We don't have a class after this, so we keep recording. So that way it's there.
Okay, so we can hit close here, and now we have our terrain represented in RAS, and it looks pretty sharp. If we zoom in here on the channel itself, here's a great example. We can see where we might have flow in a higher flow regime, but right here is the water surface. You can tell by the long triangles. So we actually don't have the underlying bathymetry here. I think I talked about this last time. So we don't have this here. We also have a culvert here along the road. So if we were going to be doing modeling with this, we'd represent this as a culvert. Sometimes you just want to leave it open because you're not interested. So we'd have to go in and edit that. But this is just showing the resolution that we have. And it's pretty good. So let's see. Let's go to our analysis here. So we want to make some measurements. So let's first define our reach, and then we'll make some measurements. So we'll do that using the geometry. We're going to click add new geometry. So if we right click, we'll add new geometry, and this will just be, I don't know what to call it. We'll say tutorial. And we'll hit OK. So now we can add multiple rivers, cross sections, etc. We're going to start with the river, and we're going to right click on that and select edit geometry. Actually move this over so I'm not blocking it. If we want to click around, we can right click to move our map once we start drawing, or we can just click with the scroll wheel.
Why don't you enlarge that?
So where do you want me to start this at?
Well, I mean, typically you're going to define the channel.
Yeah, do you want to go upstream?
Yeah, I think we should
this
go from
direction?
downstream to upstream like HECRAS normally does it. I mean,
Okay, so we'll start downstream.
is Mapper smart enough to start from downstream?
I think
to
it's
downstream?
I think it starts from upstream. We can double check the flow direction. We can reverse it if we need to.
Okay.
So
I always thought it went downstream to upstream, but
well, let's try it that way. All right, so we'll just kind of click through here. I'm going to go this direction with it. You can get as detailed with this as you want, or I mean, you can't be too coarse. So I'm going to right click, and that will pan the screen over. I shouldn't come right at this point bar. Right click again. Just kind of follow this along. And we can actually add multiple, we can add junctions. So maybe we'll do that. I'm just going to split this difference here.
You can see even with the 10-meter DEM resolution, it's pretty good. That 1 meter is going to be really good.
Yeah.
Let's stop it right there. Just
So
you
we'll
just
just,
double clicked, right?
yep, I just double clicked. We'll say little piney and hit OK. Now, if we're curious, we should be able to see a flow direction arrow on this. Let's maybe I need to display it. So I'm going to right click. I'm going to stop editing. I'll save edit. I'll say yes. And then I'm going to go and look at layer properties. I'm going to turn on the directional arrows and hit close. Yeah, so it has it backwards. So let's see.
Sorry.
No, it's okay. Let's edit geometry. Let's select this. We should be able to, if we right click, we can reverse the selected line. And now it's pointing downstream.
I had it planned that way.
Perfect. It's a great teaching moment. If we wanted to, we could also select Little Piney upstream here or Beaver Creek and then join them to this, and there'll be a junction. But I don't think we want to do that today. Yes, I do want to save the changes. So you can see River 1, Little Piney. We can go in and add our cross sections.
Okay, so at this point, adding the cross sections is where you're going to get the cross-sectional geometry.
Yep. So typically we're going to go perpendicular to the flow. So this cross section would be something like this, maybe, which is kind of weird, but if this was flowing full, that's how you'd want to split that. If you're just looking at like smaller openings, you could leave it as something like this, but this is in a small, I don't think it needs to get up that much to inundate that area. So be thinking perpendicular to flow for your openings or for your cross sections. This would be a good one to get some interesting features. We'll come down here. You might select more interesting locations. This one's actually probably like this. Start one there. I'm going to hit escape if I get into one that I'm not interested in. So we'll do this one. This one's probably like this. And there's I don't know if we're going to offer these courses in the future, but we did a one. It was unsteady flow or hydraulic analysis, and when I took that, Dr. Wilson went into like a lot of detail talking about deciding these cross sections. So I'm by no means an expert at this. I'm just kind of doing some general stuff. So we've got some cross sections. Add one more for good measure. We'll stop editing. Actually, we'll come down here to compute, and we'll just click all cross section attributes. Okay. Since we're pulling our cross section info from the digital elevation model, we can just go ahead and click that, which includes the elevation profile from our DEM. So if we have survey data, we wouldn't want to do that because it would override it. We will have to go through and hand include our survey data at these cross sections where we have surveys. So if we update, it's going to override it. But we've updated those. Now we'll stop editing and we'll save our edits. If we want to get, you mentioned valley slope. And I'm trying to think, probably the best way to do that would be to create another river. So if we edit this geometry.
Well, show them the first what you've got for this.
Okay.
Get the slope map, then we'll go to the valley slope.
Okay, so I'll stop editing. No. I want to open my geometry. So if I come back to the main interface here and I click this button, it's going to view our geometric data. I will open the geometry data and it should be there from our RAS mapper. And I'll hit OK. So now we have our geometry data. I'm going to minimize RAS mapper because it's kind of getting confusing on the screen. And I'll zoom in on this. So we can see all of our cross sections. We can see our reach. If we click cross sections, we can actually see what the cross section opening is. So up here, we have our valley walls. And if we want to look closer at the channel, we'll click zoom in and we can click and drag over that. And we can see our channel right in here. If we want to get even more zoomed in, come here. We could also stretch it out. I'm going to just click through these so we can see what they look like. This is the next one.
Notice the pink circle corresponds to what cross section you're looking at.
Yep. And I'm going to go downstream here so you can kind of see our channel cuts here. Just go through and look at them. This is a good example here of the water surface. So if I zoom in, I talked about this on Wednesday. I'll zoom in again. This is our channel here, and you can see where we have this line with no points. All right, that is just an interpolated surface between where we have data, which we don't have data there because there was water there when the LiDAR was flown. So to get some of these, Dr. Holmes talked about estimating, depending on your river, if you're familiar with it, a foot to maybe 3 feet of depth. Let's see if that was a chat. No chats. So you might have to do some research on your reach, whether that's hopping into like a Google Street View and looking and just kind of making an estimate on the depth there. So anyways, you can get all your geometry from that. These are all XY point or XY where our Y is elevation. I'll show you the slope since some people got a skedaddle. If I click, I think it's
so that's one. Getting width, that would get channel width and depth. All right, off of these. And so basically you're looking at, okay, here you've got the cross section you're at. We want to go to a riffle. So we want to go to the narrowest part of the channel and get the depth off of that. And you're going to scale it. Now he's on this channel slope. So he pulled up a different graph.
Yeah. So do you want me to pull up the cross sections again?
Yeah, pull up. Yeah. So just show them real quick. Just kind of put cross sections there. You can zoom in and you're going to have to make a judgment on what you would call the width and what you call the depth. Okay.
Yeah. So if we want to get our slope, we can look at the profile. So if we click this option here, view profiles, here's our ground profile. We should be able to click these points.
I don't know that they caught that, so go back.
If you click this button up here, view profiles, it's right next to the cross-section viewer. You have your whole channel profile, which we can click points and it will tell us their X and Y. So X main channel distance, this is like 3 kilometers. This is at the upstream point, or this is actually, upstream point. And then we come down to our last cross section. And that's just some simple math where we can get our slopes.
Now go to the valley slope thing.
So if we wanted to do the valley slope, we would define a new channel and we're just going to use it as a new reach. And we're just going to use it as our profile line. And we just click it along the valley where we're interested in getting that slope and do it that way.
So go ahead and do that really quickly.
Okay.
Because I think that's going to help them.
Okay, so let me close my geometric data and RAS mappers down here. So I'll edit my river layer. I'll create another one, another reach actually here. And I can just go down the midpoint of the valley. Now, something to note here, where you click these points, it does matter, right? So if I click it on the berm here, I'm going to have an increase upstream. Or if I click it down here in the channel, it'll be lower. So I'm just kind of clicking in the floodplain. Maybe there's a better definition of how to define the valley. If we clicked up here, it seems offline, but you know, we do have a reservoir right in the middle of the valley. So I can just label this valley slope reach. Oh, I'm limited. So we'll just say valley slope. Hit OK. And then I will stop editing, save, yes. If I want to view that, when I click on my profiles, it's saying River 1 Little Piney, right? So I can click on my reach and then go to the valley slope, turn that one on. I think I need to add cross section for it to do it. So this is some of the intricacies. Let's add a cross section, edit geometry. Actually, let me see. It might not be easy to do this with.
You may have to create a separate
Let me turn.
HECRAS project, huh?
No, you should be able to do it. Let's see. I think I might need to go into the geometry data and just set its. So if I go to cross sections here, select the reach, River 2, valley slope, and then add new cross section. River station, we'll say 0. Okay, let's cut from terrain maybe. We might just need to make a new geometry for valley slope. So if you make a new geometry, add the reach, you should be able to add the cross sections right on top of that. That's how I'd go about it.
So for those of you kind of confused at this point, why it's not showing, Kyle put the new valley slope line in there, but it won't plot because it doesn't have cross sections. So you can go into that and you can add some manual cross sections, just 0, 100, whatever you could create just 2 points on the cross section, couldn't you?
Yeah.
And just add them by brute force, just a couple points, just so it get it to plot.
Yeah. So no, that's a good point.
I don't know. You'd have to.
It might be easier to create another geometry, right? So you can have valley, a valley geometry. You have a reach. You have 2 cross sections or 3 or whatever.
So let's try to do that. Can we do that really quickly?
Yeah. So let me go ahead. Let me edit this one. I'm going to delete my valley reach. Okay, that's gone. We'll save this. And then I will right click on geometry, add a new geometry, and this would be valley.
Yeah, I think that'll keep it cleaner.
Hit OK. So now I've got tutorial channel and I have valley. So I can turn off the tutorial channel, and now I just have a blank canvas on which to generate my information. So let's edit the geometry for this river. We'll click down the middle of the valley, roughly. And we can say valley. And I'm actually going to name this River 2, just to keep things straight. We'll add a cross section down here. And we'll add a cross section up here. And then I'll stop editing. Actually, I'm going to compute all my attributes. Then I will stop editing. And I will save. Now, when I go to this profile plot, I should be able to, let's see, I need to open my other geometry. So if I go to geometry, file, open geometry data, and select the valley, hit OK. Here's our valley. If I look at this profile, turn on valley 2, there's our very general valley slope. All right, you might add some other points and kind of take the average. Because, you could have a really steep portion here, and then the rest of this is like pretty flat, and then you have another steep portion. Like, is this a true representation of the slope? Maybe not. With those, though, I wouldn't be too concerned about like making your cross sections perfectly perpendicular. You're really just interested where that cross section intersects the reach is where it's going to generate an elevation point. So if I look at this, I'm looking right here. Let me minimize this. Maybe I need to be a little more careful with my valley slope here, or maybe not put a cross section right here, right? Because it's going to be influenced by the channel. So
Let me really quickly show you something too on the arc length issue. So I think what we're going to do there, or what I would recommend, just for the sake of this exercise, is to create another geometry and basically call that maybe valley arc length or something. And then essentially what you could do in the mapper is, let's see, turn that on. How do I turn the, still got the river valley on
if
there?
you just click on valley and then just click it twice, the little checkbox by valley. There you go.
Okay, so we've got to do something here with the arc length, and so let's see what we want.
You can
Pass, is that what?
you could add a reach and use that, like use the distance on the reach to measure it, or you can I would add cross sections and then you can put stationing on them.
Yeah.
And it'll have the measurement.
So what I wanted to do was just basically, I want to call this my arc length. So you see this meander right here?
Yeah.
So if we just basically, I just want to create a reach from here on through here.
Yeah, and you should have a reach length.
Right. That would give me a length and everything. Then you could just basically get the points from right there. That'd be the arc length.
The other thing you could do if you wanted to in QGIS, create a shape file that's a line, click through it, and then generate that information in the attribute field.
All right, so that gives me the edit geometry.
So now, if you click on river here, I come down to arc length, click rivers. Now you have the tools in the top left corner.
Yeah, okay.
And then you're on the create feature.
All right, so basically then I would just kind of come through here and get this. This would give me my arc length. Okay, just right click. So just arc or something like that. And so let's see.
Now right click on it, or you got to select your vertex tool. So it's right next to your creation. You hit the edit feature and then click on it once. And now right click on it. You can generate cross sections. You can plot the terrain profile.
That's fine.
And so
that gives you a link though.
Yeah.
So from that to that, you've got basically 600, 550 meters.
536.
Okay,
549. Yeah, 550. Right.
So that would give you inside a quick and dirty tool to get the arc length. Okay. So again, play with this. This is a value. I mean, even just beyond just this exercise for the mini project, HECRAS is a powerful tool that you're going to use in practice. And so learning all these features and how to manipulate things around here.
And this might be a better way to do the valley profile, because you can click table and you can pull those points right out.
Yeah.
If you're going to be doing computation.
There's a lot of stuff in HECRAS, and unless you use it all the time, finding everything in there is like, there's a lot of stuff there. And so any questions? You guys feel a little better about trying to get this thing done? Okay. Ian?
Yeah.
Use your microphone.
So just kind of curious, what would the use of having the valley slope?
That's the sinuosity. You have to have yeah, it's the ratio of the channel length to the valley length. Or no, the channel slope to the valley slope. There's different ways to define the sinuosity. That's one of them. You could also have channel length versus valley length, and there's all kinds. But I think in this particular hay and thorn paper, they use the slope of the channel divided by the slope of the valley in order to calculate the sinuosity. I'm going by memory. Yeah, you just have to, again, you got 2 or 3 slides there. You got the HEC 20 manual. I'm telling you, use that to make your assessment of whether you're in equilibrium on this gravel strings. So that's, it's just taking one paper's opinion on what's equilibrium, and you're making an assessment based on those equations and the way that's written up. Clear as mud.
So the slide art data? Is that like the drone surveys? Is that how they collect this data?
Yeah, or they'll fly it through with a plane.
Yeah, typically they fly with a plane, this level here, yeah. But like you can do ground-based, so we call it T-LiDAR or terrestrial
That's me
LiDAR.
doing that next week.
He's doing that next week, yeah. So you set up and you got things up on a tripod. That's when you're getting like I've done that with we've had some floods where we've had dams fail, basically threatened. And so kind of monitoring the slope failure. So you can set that up there and they'll scan it and they'll come back the next day and scan it and look at the difference because sometimes just visually you can't tell if it's changing. But with the LiDAR data, man, that stuff's really detailed. And you can run some software and look at, how much is that the additional failure, the slide, how much is it moved? So
Yeah, I was taking a remote sensing course in the geotechnical engineering or geological engineering, and they were talking about LiDAR, and some of the stuff they've done with it is like basically seeing through camouflage. So they'll take a LiDAR scan and then another LiDAR scan, another LiDAR scan, and it can filter whatever foliage might be in front of something behind it. And they've also done that where they're monitoring like erosion on the quarry wall up here on 63. Well, you have like vegetation that might be between you and the rock wall, and they were able to filter that out and just get the wall. So it's really cool stuff.
that's cool.
And it's also nice for this because you get really good resolution.
Okay.
Yeah.
Ben?
Is there a way other than just going out in the field to get the bathymetry of the channel?
You could look at published studies, but I mean, you would go search this USGS science base and see if there's been any work done, or maybe the Corps has published studies, and you'd have to dig through the data and find the bathymetry surveys. And who knows when those were done. So really hit and miss on that, I think.
So I'm going to pull over on the thing here. If you get really crazy on this review or this mini project, you can use some of the other relationships like meander wavelength and meander, amplitude. If you want to throw that in and look at that, because it's very easy now to be able to scale this stuff off the maps of kind of what you've got for double amplitude, what you've got for meander length, or wavelength and stuff like that. But again, your base is going to be that Hay and Thorne set of equations that are in the slides for gravel streams. And again, this is something to stretch you a little bit. You learn some new tools, and you're trying to make an assessment. All right. Any questions online?
I've got one question, Dr. Holmes. I'm wondering about finding the mean diameter for.
Great question. So I've got a particle size analysis I did. I grabbed a set of rocks out of the creek and ran sieve analysis on them. I will, if for all else, just assume, so 2 millimeters is the break point between sand and gravel. And so I'm trying to think here what's the best to do, because some of you already moved along, but the medium diameter,
What about
do you guys have
what about the diameter analysis they did last semester?
did they do that?
Well, we did the rock counts.
Oh,
Get an
yeah.
estimate.
So
How many of you were in water resources last semester? Okay, so you should have your field lab. where you did
yeah,
the
and
rock
so
count,
can
right?
you guys email me do you have those results?
I could probably go find.
So if you've
them.
got
Might be easier.
your lab from what you have, Catherine, maybe you could email those to me and I'll just share them out with everybody. And we'll just, that's where you
It's
get this.
pretty representative.
Yeah,
I would say.
Yeah, I mean, you're not going to get much, I don't think you're gonna get much variability between the little piney and the current. It's about the same distribution of
It
gravel.
just would depend on where you took your sample.
Yeah. So we'll just use that. We'll use whatever Catherine's got for particle. That's a great, Zias, that's really a good point. I've meant to mention that because you don't have the D50. Some of them use D84, right? I don't have.
Right. Yeah, I think there were a few that used D84, but D50 was the most common one.
Yeah. Yeah, here's the hay and thorn stuff. Yes, use the D84 there and the D50 for the bank full slope. Okay,
All right.
yeah, Catherine will send that to me and I'll get it out to everybody. I'll post it. All right, thanks you guys. Hope this is helpful. Thanks, Con.
Yep.